Okay, we're going to take a look at a review before the final exam for fundamentals of algebra. Let's move this out of the way and go ahead and get started. So there's going to be a good deal of graphing. Let's take a look at that. So if you're graphing something like this, your boundary line is x equals 3, which is a vertical line. Remember, you have some friends, Hoy and Vux. A horizontal line has a slope of 0, and the equation for it is y equals. A vertical line has an undefined slope, and the equation for it is at x equals. So if you remember Hoy and Vux, if you see an x equals line would be a vertical line. So I need x equals 3, that's my dotted line. If it's less than or greater than either of these, it'll be a dotted line. If it's underlined here, less than or equal to, greater than or equal to, those are solid lines. If that symbol is underlined, it's solid. So in this case, we need a dashed line, so that's what we have here. And then we want the location where the x's are less than 3. So go to the x-intercept here, and where are the x's less than 3? This direction. So that's why I've shaded all of this. Next one, we're here going to graph a system, and this is different because it's an equation, a system of equations. This one was an inequality. Inequalities, you need to check solid or dashed and shading. For equations, they're always solid lines, and there is no shading for this. So 2x plus y, I'm going to put into slope-intercept form, so y equals negative 2x plus 6. So I've got a 6 as my y-intercept, just right here, and I want to go down 2 over 1, down 2 over 1. This is a negative slope, so I want to be going downhill. Here I've taken second equation, and it's got, when it's solved for into slope-intercept form, I've got y equals negative 2x minus 5. So negative 5 is my y-intercept, and again, I'm going down 2 and over 1. They have the exact same slope, but they're different y-intercepts, so the lines are just parallel. So when we talk about solving the solution and finding the solution set, there is no solution because they don't intersect. Here's a horizontal line. Remember your friend again, Hoy, it's a y equals line, so you know it's a horizontal line. This is an equation. It doesn't have it doesn't have to be considering of solid or dashed or shading because it's not an inequality. If this was y is less than or equal to 4, I'd be shading down below here. If it was y is greater than or equal to, I'd be shading here. But y equals 4 is simply a line. In number 4, I've got two different inequalities. See, this one is a solid line. Number 1 is solid, and number 2 is a dashed line. I've put them into slope-intercept form. This one has, line number 1 has a negative slope, so it's going downhill as we go from left to right. And the second one, notice that right here I had a negative 2. When I multiply or divide on both sides of the equation by a negative number, it's going to change. In the next step, I change the direction. So I change from a greater than to a less than. So I've got a negative 3 here as my y-intercept, and I'm going up 3 and over 2 in a positive. So this is a positive slope of 3/2. When you are shading, think about number 1. I want y's to be less than or equal to this line. If I have it in slope-intercept form, I can say I want y's to be less than the line. So this line here with the 4, I want to go to my y-intercept and decide where to shade. Think of it as above or below. Don't think of it as left or right. Always think above or below. So I want y's to be less than, that would be below. So that's why I put these arrows here to remind me to stay below that line. For this one, I want y's to be less than the line. And so here I'm going to have to stay below this line also. To stay below both of them, I need to be shading in this region. We need to also name the quadrants and the axes. This line here is the x-axis. This is the y-axis. And the quadrants run 1, 2, 3, 4 in a rotation. The reason is this is the line in trigonometry where we start an angle in standard position and then they go around like this 90 degrees, 180, 270, and back around to 360. That's why they go 1, 2, 3, 4. A lot of times we think it should be 1, 2, 3, 4 the way that we read, but that's not true. Here we're simplifying. Remember, base, base, add, and power, power, multiply. So we're doing a power of a power, so we'll have to multiply those numbers. So we also have 2 to the third power. 2 times 2 times 2 is 8. Here we're using a distributive property, so negative 4x squared times each of these terms. Get this. If we square something, that's 5y minus 3 times itself, and then we'll use FOIL. Here, if we're dividing by one single term, then make a fraction of each of these terms over that bottom and simplify each of them by themselves. This is double distributive. I'm going to take the x times each piece, and then finally I'll take the negative 5 times each. So I'll have to get 6 items, and then I'll simplify them by combining the like terms. Here we have a binomial times a binomial, so we're using FOIL. This one, be careful, because of the parentheses, we think that we should multiply, but that's not the case. This is subtracting, so we're going to take the negative times each of these terms, and then combine the like terms. Here we're taking the absolute value. That tells us the distance from 0. So negative 10, its absolute value is positive 10. Distance is always positive. This one, we find this to be the absolute value of negative 4, which is a positive 4, but then there's a negative 1 times it in front, which gives us a negative 4. For number 15, what I've done here is I'm going to work inside the parentheses first. If I have an n to the negative 2 on the bottom, that would be the same as if I moved an n squared to the top. And an m to the negative 4 on top would be the same as an m to the 4th in the denominator. So I've gone ahead and cleared out my negative terms by rewriting them. Now I'm going to take each term and square it, each of these values, and square it, and that's not what I did. Wait, I've got something else to simplify. This is a base, base, add, so I've got n to the 8th power right there. And m to the 3rd times m to the 4th, base, base, add the powers, so m to the 7th. Now I'm going to take this and give the square to each of these. So power of a power, we multiply. 2 times 7 gives me 14 there. And then I don't have any other common factors in top or bottom of the fraction, so we're finished. Here's another FOIL problem. Let's see here. It says evaluate given that x is negative 3. We were substituting, dropping it in parentheses, that negative 3 into each spot where we have an x and finding our value. Find the slope of the line through these points. So change in y, and this is a little delta, that means change in. So change in y over change in x. So take the y's first, so negative 4 minus negative 17, and then on the bottom it's 3 minus negative 5. Why is there an 8 there? I don't know. I think I moved ahead. Okay, this right here should be a 5. I'll have to fix that. And then we would get 3 plus 5 is 8. I think I was thinking of the 8 already. Remember, when you find the equation of a line that goes through 2 points, calculate the slope first. So change in y's over change in x. Then you must always calculate the b. Sometimes people think that this y or this y will be their b. That's not the case. You have to calculate it. So substitute your slope that you found. We're taking that slope here. And one of your xy ordered pairs. I picked that one. And solve for b. And that can be written in as your y-intercept. If m is negative 4/5, find the slope. Parallel is going to be exactly the same slope. perpendicular slope must have the opposite sign and the reciprocal. Here's another example that we're using to just solve for a value. So we're using the distributive property and then combining like terms. We want to write these in standard form, so we want our highest power term to come first. So I've rewritten this in standard form. Then the degree and leading coefficient, the highest power on a variable is 8, so that's the degree, and the number in front of it, the leading coefficient is -1. Down here we're going to solve a formula for m. So I want to get m by itself, so I'm going to subtract the nx, and then after that I'm going to divide by O on both sides. Remember, that's an O and not a 0. Also remember that upper and lowercase symbols must be kept that way, so like a large case n is not equal to a lowercase n. You don't get to change the style. Here we're solving a system. So we have two equations with x's and y's. Let's eliminate. You could eliminate either the x's or the y's. I just decided I was going to do these. They were single-digit numbers where I had a 14 here to work with. So I need to get one positive and one negative and have the same number in front, except one is positive and one is negative. So if I multiply this first equation by -9 all the way across, and then the next equation by 4 all the way across, then I can go ahead and add these, and those x's will cancel. When I do that, I'm going to get -106y equals -530, and I could solve that and get my y equals 5. Now I could take this y equals 5 and put it back into either one of these equations. I chose equation number 1, and I substituted in and found out that the x was -6. And then I just made an ordered pair. Here's a system where you have 3 equations and 3 variables. You need to choose one variable to completely eliminate first. I picked z. I could have picked any of them. This one looked easy to me because I had the z and the negative z. They would add together and eliminate right away without doing anything else. And then I could take this negative z here and multiply that equation by 6, and I'd have a -6z to eliminate with this one. So that's what I did first. When you do that, you get 2 equations with just 2 variables. So see how I've eliminated the z's from all of my equations. Now I'm going to take these 2 A and B level equations, which have just x's and y's, and I'm going to use them to do one more elimination. Once I do that, I can put this back, this number where x is equal to 4. I can go back into either of my A or B equations. I chose B, substituted back in, and found my y value. Once I knew my x and my y, I could go back to one of the earlier equations. So I went back to number 1 and found that z was 3. So that gives us a unique, just one solution for -2 and 3. So these are x, y, and z. Be careful as you work. You might get something like 2 equals 2 or 0 equals 0. And those are always true. So that would be an infinitely many solutions. And if you get something like 0 equals 5 or 2 equals 3, for example, those are always false, so you'd have to say no solution. This is considered to be inconsistent. This is consistent and dependent. And when I have just one solution, that's consistent and independent. Here are just some translations. So we have some English and we're writing it back into math terms. Let's see, here's another one of those where we have to write the equations ourselves. So Haley bought 3 paper fans and 9 bears for $43.50. Kate bought 8 of each for $52. How much did each type cost? So these are total it up equations. So 3 times F, and F is the number of paper fans, plus 9 times B, and 9 is the number of bears, is $43.50. And then 8 of each, those amounts would sum up to $52. So I'm thinking here that I'm going to do an elimination. So I'm multiplying the first one by a -8 all the way across, all 3. And then the next one, I'm going to multiply equation 2 by 3. When I do that, I get a 24 and a -24 in front of the F. So those will eliminate when I add the 2 equations. When I add those, I can solve and get b equals 4. Then I can take that b equals 4 and put it back into one of these. I just chose one and figure out what f is. Once I know that, then I give my answer. And here's one more item. Let's see, there's a banquet table problem. I think we had one like this on a test, and some people had problems with it, so I wanted to talk about that. The table is 4 foot longer than 3 times its width. If the perimeter is 56, find the dimensions of the table. So I let x be the width. So 3 times the width plus 4 is the length. Perimeter is twice the length plus twice the width. And I have an expression for my length and width that I could put into there. And so I know my perimeter is 56. And I solve and get x equals 6. If x is 6, 3 times 6 is 18 plus 4 is 22 feet. So 6 feet by 22 feet is the length of the banquet table. And here's one last slope problem. We're trying to find a parallel line, the equation for it. And so 2/3 is my slope. I need the same slope because it's supposed to be parallel. If it was going to be perpendicular, I would use a negative 3/2. So I'm going to take my ordered pair, which is an x and a y, and substitute the x and y values into that equation, y equals mx plus b. I'm also using the same slope, 2/3, because like I said, I need a parallel line. When I did that, I found that b was 9. Remember, you always have to calculate b. B is not going to be part of anything that's given to you here in this problem. You have to calculate b. And then you're going to write your equation using the correct slope, the new slope that you had, which actually was the same as the old slope, and your new y-intercept. So you're subbing in, and you'll have your x and your y will still be in your equation. I hope this review helps.